Block number 3, contemporary cosmological theories. Unit 1, theories of relativity. 1.1 Introduction. The advent of the theory of relativity and of the quantum mechanics has revolutionized the whole domain of science. They question some of the age-old concepts such as absolute motion, absolute space, absolute mass, wave nature of particles, unlimited perfectibility of experimental results, etc. They thought in certain radically new concepts and gave new insights into several baffling phenomena in nature. Towards the end of the last century, it became evidently clear to scientists that the real driver force in scientific inquiry were in the fathomless depths and intergalactic space at the. Hello, sir. What type of pastry is that? Medium hard, classic butter. Wait, it's medium, it's hard pastry. This is hard pastry. Deep dish. What pastry are you looking for? Easy. You can go for Swedish. What is the difference? Swedish and Balinese is with a medium pressure with a mist. This is with everything is with oil, okay. But this is Arabic. Okay. So 60 minutes. Huh? 60 minutes. Till what time is it? Last appointment by 9 o'clock. 9 o'clock. Can I give you a number? See the room? The room and the massage. The therapist? We have local and Northeast. Yeah, all good therapists. Okay. Why don't you take now? No, I have to go to a place and come within 15-20 minutes. Okay, absolutely. Thank you. Hi. हाँ 15 मिनट में आएगा बोला 15 बोल के तो गई है So the all pervasive importance and relevance of relativity in theoretical science of today We give a few quotations from the leading writers. Thus, H. Marganew writes, "In fact, the theory is now so well corroborated by experience and by assimilations into whole of modern physics. Empirical verifications, but above all by the intrinsic beauty of its conception, which philosophers the discriminating mind the acceptance even if there were." Bye. No experimental evidence for the theory at all. Again, Hutton relativity has. Hello, good evening, Sulispa. ये till 11 तक. हाँ, 11:30 तक रात में. Starting from 3,500. सर्विस आपको फुल बॉडी ऑयल. आप कौन से प्रेशर कैसे प्रेशर लेना चाहेंगे, मीडियम और हार्ड? हार्ड में आपको फुल बॉडी ऑयल मसाज, स्ट्रेचिंग, ड्राई मसाज एंड स्टीम शावर. यस सर. ये विले पार्ले. हाँ यस. हाँ, ऑर्किड होटल के बाजू वाला होटल बिल्डिंग. हाँ हाँ, ऑर्चिड होटल के बाजू में टर्मिनल 9 बिल्डिंग है, उसमें है सेकेंड फ्लोर पे. लोकल है, नॉर्थ ईस्ट है. लोकल है, नॉर्थ ईस्ट है हमारे पास ट्रेनर. हाँ, चॉइस देते. 10:15 बजे. हाँ हाँ, चलेगा ना. हाँ हाँ, आप आ जाइए. आपका नाम क्या है सर? मिहिर. ओके, ठीक है. मिहिर आने वाला है. हाँ, 10:30 को. फिर मैं उसको 3,500 को दी. क्यों? डिप्टी शुगर नहीं, हार्ड मसाज चाहिए. 3,500 मीडियम अगर लिया तो टिप्टी. मतलब 3,500 रुपये किधर है अपने पास? दे दो ना. एक दे तो ठीक है, बट ऐसे बोलना क्यों? रॉन्ग कम्युनिकेशन होता है ना. फिर यहाँ पैके लेकेगा तो क्या करती है? अगर हार्ड मांगा, डिप्टी शुगर पूछा है 4,500 रुपये, 1,000 रुपये का लॉस करेंगे. आएंगे तो बात करते हैं. कितने बजे बोल रहा? 10:30. मैंने उसको ऐसे बोला, वी आर स्टार्टिंग 3,500 है. मैंने मतलब ऐसे बोला मैंने उसको. अभी सैटरडे का संडे सिफोरा जयदीप संडे को सिफोरा मॉर्निंग आते हैं. तुमको आना है ना? मतलब देख ले लड़कियां है क्या एडजस्ट हो रहा है तो ही बोला. ये कभी कि मैं 9:30 को आती हूँ. कल ये भी लेट आने वाली दिखती. कितने बजे? 10:30 तक आएगी. तो कहाँ जाएगी? कल या मंडे को दिखती. नॉर्थ ईस्ट में ये जेनिफर का कभी मैंने उसको ही देख लिया. तो आरोही है ना? अभी आरोही दीदी. आरोही आफ्टरनून में. अभी नहीं है. इसको आरोही चाहिए था. अरे आज छुट्टी पे लिखो वीक ऑफ है. और तूने ओके लिखी है. कौन लिखा है इसको? ये पहले लिखा था, अभी इसने बोला है. कौन है? तो ये आज का नहीं ना बाबू. आरोही चाहिए. पूछ. हेलो, कौन अवेलेबल? आरोही नहीं है. आरोही वीक ऑफ नहीं. आरोही वीक ऑफ नहीं. कौन अवेलेबल? रातों क्या बोलो? रूपाली, अर्जुन, माया,
सानिया जेमिनी लिखो न्यू स्टाफ है सानिया राठौर लिखो लिखो न्यू स्टाफ है दे मेरे को नहीं है नहीं है क्या बोला भी नहीं था सिर्फ है मॉर्निंग और उसको ये बाद में डालना है क्या
सानिया
किस नहीं छोड़ा ना डाल देते हैं मैं बोल रही थी तो और ये जेनिफर को जेनिफर आफ्टरनून पक्का अभी दो लड़की लोग आफ्टरनून आएगा ना ऑफिस एक ही है एक ही बच्ची ना तीन ही है ना तो अभी 2 आफ्टरनून करेंगे एक मॉर्निंग करेंगे
मॉर्निंग में नहीं आते ज़्यादा मॉर्निंग में एक ठीक है
एक ही रखेंगे मॉर्निंग आफ्टरनून में 5 लड़के कब आफ्टरनून
has profoundly changed the whole of physics by the analysis of the fundamental concept of space and time, of mass and of force. It has given a new orientations not only to science but also to our approach to philosophic problems in general. Before Einstein, physicists were confident which they understood distance, time and mass. They believed in skilled person. हाँ
बिल्कुल नहीं बट एक को नीचे डालना पड़ेगा
believed in skilled person could measure distance with a ruler, tell time with a clock, weigh mass with a scale, and get the true values with his theory of special relativity. Einstein proved that this was wrong, that these are no true values, and that he shook the very foundations of science. Einstein developed two theories of relativity, special relativity and general relativity. Special forces. It was followed 10 years later by general relativity, which includes Einstein's theory of gravity and is the more complex theory. 1.2 The theory of reality. In everyday language, we can say that relativity is a theory. क्या ये मतलब?
ऐसा बोलो रोना पका रही मेरे
इसको पकड़ के मसाज दे देते
जैसा तुमको मसाज करना
हाँ थोड़ा बहुत आता है बट बेसिक आता है मम्मी पापा को
मसाज आता है कि मालिश आता है बता मालिश आता है
मालिश
आता है ना
मालिश मतलब मम्मी पापा को करती हूँ ऐसा ऐसा
मालिश तेल मालिश आता है छोकरे को खाना बनाना आता है लाती तो नहीं बनाती
हाँ
क्या बनाती है अच्छा
आज बना के लाई थी ना दाल खिचड़ी
और खुद ही खा गई ना पूछती तो मैं कोई खाएगा अरे मुझे पाव खाना है पाव और चटनी
कल मैं सोयाबीन बना के लाती हूँ सोयाबीन
कल संडे हम लोग देखो चारा नहीं आता तो संडे नॉनवेज नहीं खाते मॉर्निंग में भी नहीं खाऊंगी ये सोयाबीन ला टिफिन लेना इसके लिए सोयाबीन टिफिन ले देना
नहीं नेक्स्ट डे लाती हूँ
ठीक देखते हैं मैडम बोली तो मैडम छुट्टी हाँ नहीं तो आजा ऐसा मत कर
In everyday language, we can say that relativity is a theory which holds that concept like motion, length, time, mass, etc. Not absolute. They make sense only when referred to a frame of a reference. The such astronaut of mass say 8 kg on the surface of the Earth's first frame of reference may have a mass of 100 kg filled inside a fast-moving rocket. Second frame of reference. A different definition is given by Eddington and Institute, which leads to the conclusions that we observe only relations between physical entities. 1 minute.
Yes, take 2 minutes, baby. Go 42 and come. You go there. Chai pee.
Then,
The chai pee na please. Bread. सोने में यूज करना आता होता है मम्मी को भी कॉल करती
नहीं रुको। बड़ा पत्थर दिल पर काबू किया। क्या हो गया बेबी? What happened? Matches 100 kg fight inside a fast moving rocket. Second frame of reference. A different definition is given by Eddington and Attitude, which leads to the conclusions that we observe only relations between physical entities. Spatial and general theory and relativity. Einstein published his theory in two papers, once in 1905 and the other in 1916. The forms the spatial theory and it deals with only uniform motions of bodies. The second is called the general theory, and this deals with the moving bodies, including those with non-uniform velocities, that is accelerated bodies. Postulates of the spatial theory of relativity. Einstein explained the negative result of experiment in the form of two postulates. Postulate I, it is impossible to determine absolute motion by the experiment whatever so in the universe, so privileged frame of reference with respect to which absolute motions can be measured exists. Hence the phenomena of nature will be the same of two observers who moves with any uniform velocity whatever relative to one another. Putting it in another way, we can say that uniform motion does not affect physical laws. The general laws of physics are the same in all systems moving uniformly with respect to each other in a straight line. This is called the principles of relativity, from which the theory gets its same. Postulate second, the velocity of light is a constant absolute quantity. It is independent of the motion of the source of the observer. Implications of consequence of the postulates. Impossible to measure the uniform motions of a body by observing events taking place within the body. According to the first postulates, all natural events are affected by uniform motion, so by observing them from within the body moving with uniform velocity, we can't measure in velocity. Consider a train moving with constant speed. Everything inside it happens as through it in motionless. 1.3 relativity of motion, length, time, simultaneity. We must give up the classical platform of an immobile framework of space. It is meaningless to talk of absolute rest. All motion is relative. It makes sense only when referred to a frame of reference as an illustration. Consider a station master of the platform and all engine driver in moving train. The station master will say that the engine driver is moving with respect to him. The engine driver, on the other hand, will say that the station master is moving with the respect to him and his engine. Relativity of length. Length is not something absolute in the sense that it has the same value everywhere, streaming from the infinite past to the infinite future in a moving frame. Time slows down to observe moving with different uniform velocities will have different values to the durations of an event. Newton assumed time as absolute and universal. He assumed time ran its own intrinsic rate unaffected by anything else for flowing at the same rate everywhere and always. But Einstein said that all this was wrong. Time is relative. There is no one true time. Time runs at different rates in different interstellar frames. Different clocks will inevitably measure different times. Let us try to see why it is true. Time is our way of measuring how rapidly things change. If nothing ever changed, time would be a meaningless concept. Every clock counts the number of time something changes. In truth, it is time itself that appears to us to be slower in a moving frame. This is called time dilation. Hence, according to relativity, there is no absolute before and after absolute. Topological time is ruled out. Means that there is no absolute past, present, future applicable to the cosmos as a whole. Also, there is no absolute duration. This is ruled out. Absolute धीरे metric time.
तो भाई तुम मेरे हो किसके हो, तुम उसको अपनी
Space time and four dimension continuum. Herman Minkowski.
लेना देना भी नहीं, दूर भला में। हेलो सबसे सुबह से जो बात की मैं आपको सब रिकॉर्डिंग भेजी थी, उसके बाद भी आप उसका साइड लोगे क्या मेरा साइड?
Herman Minkowski realized Einstein's theory changed our understanding of the geometry of our universe. The three-dimensional space can no longer be considered distinct from time. Space and time must be viewed as a combined four-dimensional entity that Minkowski named space. Time in four-dimensional space, time points are called events, and four quantities are required to specify an event such as latitude, longitude, altitude, and time. The measurements and moral three-dimensional distance measurements are relative different from the different observers, but the distance between two events in four-dimensional space time in invariant the same for all. Relating system expressing certain general features of physical objects. Thus, they describe the world in an orderly way. It is true that they are constructs of the mind, but they are not pure empty concepts. They are concepts fit to describe the physical world. In Hassan, these vehicles walls. This conceptual system describe relations holding between physical object. In addition, these relations formulate physical laws of great generality determining some fundamental features of the physical world. Space and time have as much reality as say relation father or the Newton forces of attraction. Thus, the relations we talk of our objective relation.
मैं जानती ये हमारी बहन है।
In ordinary language, the word space itself is used to the name of continent. We can say, for example, that a part of a space has become or has the content to be occupied. Space-time, however, is a space in a less sense of this word, and because time is already in the representation, it is wrong to talk of space-time as itself changing. Thus, in some expositions of relativity, it is said that a certain world line is a track along which a material body moves or a light sign is propagated. Here, the body or light signal is propagated. The body or light signal, however, can't correctly be said to move through space-time. What should be said is that the body or the light signal lines tenselessly along the world. Time to talk of anything moving through space-time is to bring time into the story twice over and in all intelligent manner. When we are talking about motion in terms of the space-time picture, we must do so in terms of the relative orientation of all lines. Thus, to say that two particles move with a uniform non-zero relative velocity, it is expressed by saying that they lie tangentially along straight wall lines that are at an angle to another. Similarly, the recent conception of the positions as an electron moving is meant is that the wall lines of a positions and electron which are produced together or which annihilate one another can be regarded as a single bent wall time, and this may indeed be a fruitful way of looking at the matter. Relativity of simultaneity. Up to now, our considerations have been referred to a particular body or reference which we have stated as a railway embankment. We suppose a very long traveling along the rails with the constant velocity and in the direction indicated. People traveling in this train will with a vintage view of view the train as a rigged reference body coordinate system. The regard all ev- all events in reference to the train. The every event which takes place along the line also take place mm, at a particular point of the train. Also, the definitions of simultaneously can be given relative to the train in exactly the same way as with respect to a embarkment as a natural consequence. However, the following questions arises are two events. Example: the two strokes of lighting A and B, which are simultaneous with reference to the railway embankment. Also, simultaneous relativity to the train. We shall show directly that the answer must be in the negative.
मेरी माँ भी मेरे साथ है। हाँ कल जाऊंगी फोन नहीं उठा तुमको लेकिन उससे क्या लेना कल सुबह में रिटर्न फोन करूंगी देखते हो आएगी सुनो मेरी बात उसकी सपोर्ट टाइम वो पहले कहती मैंने जब उसको मालूम पड़ा कि मेरा कुछ बनता करता है तो उसने ना इसको फुग्गा को पीछे फिर वो एक लड़की है अशफाक पता है तुमको सुनो नहीं सुनो
When we say that the lighting strokes A and B are simultaneous with respect to the embankment, we mean the rays of light emitted at the places A and B where the lighting occurs meet each other at the end midpoint MAM of the length AB of the embankment of but the events A and B also correspond to positions A and B on the train. Let M be a mind point of the distance AB on the traveling train. Just when the flashes are judged from the embankment of lighting occur, this point M naturally coincides with the point M, but it moves towards the right in the diagram with the velocity v of the train. If an observer sitting in the positions M in the train did not possess this थोड़ा कम करना lighting A and B would reach him simultaneously, that is, they would meet just where he is situated now. In reality, considered with reference to the railway embankment, he is hastening towards the beam of light coming from B, whilst he is reading on ahead of the beam of light coming from A. Hence, the observer will see the beam of light emitted from B earlier than he will see that emitted from A. Observers who take the railway train as their reference body must therefore come to the conclusion that the lighting flash B took place earlier than the lighting flash A B. Thus arrive at the important result: events which are simultaneous with reference to the embankment are not simultaneous with respect to the train at vice versa. Relativity of simultaneity. Every reference body coordinate system has its own particular time. Unless we are told the reference body to which the statement of time refers, there is no meaning in a statement of the time of an event. Now, before the advent of the theory and relativity, it had always tacitly been assumed in physics that the statement of time had the absolute significance, that it is independent of the state of motions of the body of reference. But we have just seen that his assumption is incompatible with the most natural definition is simultaneously. If we discard this assumption, then the conflict between the laws of the propagation of light in vacuum and the principle of relativity disappears. In it, we concluded that the man is carriage traverses the distance b per second relative to the carriage travels the same distance also with respect to the embankment in each second of time, but according to the foregoing considerations the time required by a particular occurrence with respect to a carriage must be not considered equal to the durations of the same occurrence as judged from the embankment as reference body. Hence, it can be contended that the man is walking travels the distance w relative to the railway line in a time which is equal to 1 second as judged from the embankment. Moreover, those considerations are based on yet a second assumption which in the light of a strict consideration appears to be arbitrary, although it was always strictly made even before in introductions of the theory of relativity, that the limiting velocity of light. Nobody can travel faster than light, so the law of addition of velocity is such that the combined velocity does not exceed the velocity of light. If a body moves with the velocity of light, it would have contracted to nothing. This can never be reached or at the velocity of light. A clock will stop moving and also then durations will be infinite. 1.4 Mass and energy. The fact that body can travel faster than light suggests that our interior resistance to motion. A body increases with increased velocity approaching infinity as the velocity of light reached. Now mass is nothing but inertia or tendency opposing motion, so as velocity increases mass also increases. Mass is not absolute but relative to the frame of reference mass of a body in moving frame reference is increases and relativist correction is needed that the move very fast. Energy of motion of a body depends on its inertial mass and the velocity, so energy can increase either with initial mass or in velocity, but velocity can't increase indefinitely. Its maximum value is the velocity of light, so as energy increase the interior mass also should increase. Thus, we have the famous mass energy equation to Einstein. E is equal to mc2. E is equal to energy produced due to conversion. M is equal to mass that is converted. C is equal to velocity of light. 1.5 General theory of relativity. The general theory of relativity was Einstein's growing achievement of realizing the theory of gravitation and initiated the new field of cosmology, the study of universe. Einstein formed out the special theory of relativity in a quick 5 weeks. In contrast, the general theory took Einstein almost 10 years from first vision of final equivalent equations. The general theory of relativity was initially presented in a paper by Albert Einstein in 1915. Its primary thrust was add the effects of gravity to the special theory of relativity, making special relativity a special case of general relativity. In the same way, 10 years earlier, Einstein proposed the theory of special relativity with the primary thrust of eliminating the concept of a fixed reference frame in favor of relativity interior frames in conjunction with the newly learned fact that speed of light was a constant when measured in any initial reference frame. This theories in a similar was makes the Newton education Euclidean geometry of a space of special case of special relativity. So rather than these new theories refuting the old theories, they actually verified that the previous theories were special cases of a more complicated theory that explains more of reality. Many of us who have studied physics may remember an equation that states that force equal mass times acceleration. F is equal to mf for a mass being accelerated by a constant phase. Who also remember how strange it was that an almost identical equation, force equal mass times gravitational acceleration constant F is equal to mg was used to determine the weight of non-accelerating object in a gravitational field. That similarity or relationship between A and G forms the conceptual basis for general relativity. Consider yourself standing on a scale in a enclosed elevator at rest. Also consider yourself standing on a similar scale in an enclosed spaceship accelerating at 1 g. Both the equations and our intuitive knowledge tell us that we can't distinguish between the between the one situation and the other, we would be standing balanced on the scale with the scale reading our weight in both classes. Also consider the opposite situations where the elevator was in free fall and the spaceship was way out in space away from any star with the rockets off. In both cases, again we can't distinguish between being in the elevator or the spaceship. In both classes, the scale would read zero and we would be floating with no forces on our body. Based on this conceptual foundation, additional general relativity concept and effects have been developed. One concept is the effect of gravitational fields to cause the space-time continuum to be curved or warped by large masses. Another effect is that gravity, in addition to being light, also can cause it to slow down. The slowing down of light results in time dilations effect where time actually slows down. The slowing down effect of Earth's gravity on time at its surface is very little compared with space. The Earth's gravitational field slows down time by only 1 second per billion seconds. Experiments have verified the validity of general relativity. Some so these experiments include the precessions of the perihelion of Mercury, the deflections of light, and the gravitational rate shift of light. Although Earth with low gravitational field is at only end of the spectrum, black holes predicated by general relativity and observed in space have extremely has gravity and are at the other end of the spectrum. Black holes, in addition to bending light, slowing down light, and first year तुम्हारा पढ़ाई हो गया ना. Slowing down time can stop light from escaping and make time standing still for us watching a space probe speeding toward the event horizon of a black hole. The space probe मैं चली जाऊंगी दीदी को बोलो मैं चली जाऊंगी अभी. Probe would appear to slow down and virtually stop. The fact this science can show that time can virtually steps helps our understanding of how a transcendent God beyond time and space can exist. 1.6 The gravitational field. If we pick up a stone and then let it go, why does it fall to the ground? The usual answer to these questions is because it is attracted by the earth. Modern physics formulates the answer rather differently for the following reason. As a result of the more careful study of magnetic phenomena, we have come to regard action at a distance as a process impossible without the interventions of some intermediary medium. If it, for instance, a magnet attracts a piece of iron, we can be contact to regard this as meaning that the magnet acts directly on the iron through the intermediate empty space. But we are constrained to imagine after a manner of Faraday that the magnet always calls into being something physically real in the space around it, that piece of iron, so that the latter service strives to move towards the magnet. We shall not discuss here the justification for this incidental conception, which is indeed of somewhat arbitrary one. We shall more satisfactorily than without it, and this applies particularly to the transmissions of electromagnetic waves. The effects of gravitation also are regarded in an analogous manner. The actions of the earth on the stone takes place indirectly. The earth procedures in its surrounding a gravitational field which acts on the stone produces its motions of fall. As we know from experience, the intensity of the actions on a body diminishes according to a quite definite law as we proceed further away from the earth. From our point of view, this means the law government the properties of the gravitational field in space must be perfectly definite one in order correctly to represent dimensions of gravitational actions with the distance from operative bodies. It is something like this. The body example, the earth produces a field in its immediate neighborhood. Neighborhood hence determined by the law which governs the properties space of the gravitational fields themselves. In contrast, the electric and magnetic fields, the gravitational field exhibits the most remarkable property, which is the fundamental importance of for what follows. Bodies are moving under the sole influence of a gravitational field receive an acceleration which does not in the least depend either on the material or on the physical state of the body. For instance, a piece of lead and a piece of a world fall in exactly the same manner in a gravitational field in vacuum when they start off from rest or with the same initial velocity. This law, which holds most accurately, can be expressed in a different form in the light of the following consideration. According to Newton's law of motions, we have force, initial mass, acceleration. Where the integral mass is a characteristic constant of the accelerated body, if now gravitation is the causative cause of the acceleration, be the half force gravitational mass intensity of the gravitational field, where the gravitational mass is likewise a characteristic constant of the for the body. From these two relations follows acceleration gravitational intensity of the gravitational field internal. If now, as we find from experience, the acceleration is to be independent of the nature and the conditions of the body and always the same for a given gravitational field, that then the ratio of the gravitational to the inertial mass must likewise be the same for all bodies. By a suitable choice of units, we can thus make this ratio equal to unity. We then have the following law. The gravitational mass of a body is equal to its initial law. It is true that this important law had hitherto been recorded in mechanics, but it had not been interpreted. A satisfactory interpretation can be obtained only if we recognize the following fact: the same quality of a body manifest sections. We shall so to what extent this is actually the case, and how this question is connected with the general postulate of relativity. A new interpretations of gravity. Accelerated motions can be as equivalent to a gravitational field only because initial mass is equivalent to gravitational mass. This was known already in classical physics, but no explanation was given to it. Einstein suggested that the same quality of a body manifests according to circumstances as inertia or as weight. Thus, because of inertia, bodies in empty spaces, the space's gravitational field that travel with accelerated motion is parabolic paths. Hence, inertia and gravity are two aspects of a single law. Every body tends to move along a geodesic. The new picture of gravity. According to Newton, gravitation is a force of attraction between two bodies. Thus, the sun attracts the earth, and because of this gravitational force, the earth revolves around the sun. Gravitation causes the earth and other planets to describe curved paths in a straight space. According to Einstein, massive bodies distort the space-time continuum in their neighborhood, but the curvature formed because of this distortion deflects the planets and they move in curved paths. The paths of the planets, etc., are the shortest courses in a curved space-time continuum. Gravitation is hence reduced to the geometrical property of the space-time continuum. It is not force acting or distance, but simply is the path of inertia which the bodies follow. Massive body like the sun keeps the space in its neighborhood continually curved. It is as through the sun takes groups around it. The bodies move in these groups. Another metaphor used is that the gravitating bodies procedure heal or the deformities in the continuum, and bodies are rolled along the hillside. Backward from bartender. A gravitational force has much of physical reality as an electromagnetic field, and its structure is defined by the field equations of Einstein. Gravitational deflections of light. Now, light can be looked upon as a stream of minute particles called photons. Therefore, they also should behave like any other material particles. So, in a strong gravitational field, a ray of light should undergo deflections. This is called gravitational deflection of light.
उसे सिखाने के लिए